Good morning, children. Hope you're all doing well. Let us start our lesson. Today, we are going to start our chapter, Emotion. It's a chapter from our textbook. Everybody have some knowledge, right? What is actually the word emotion means? What do you first get in your mind when you heard the word motion? Motion, which is nothing but if an object is in a movement with respect to the time, if it is moving from one place to the other place, one from one position to the other position with respect to this time and the surroundings, then we can say that the object is in a motion. For example, you walk, you're, you're in a motion. The fan rotate, the fan is in a motion, right? The vehicle moves when driver starts the when he drives, the vehicle is in a motion. These are the few examples of a motion. Sir Isaac Newton said that a body in motion tends to stay in motion unless acted upon by an outside force. Okay, let's begin our class. Let us see what are the topics to be covered in this chapter ongoing class. We are going through what do you mean by motion, what is motion. We'll learn describing the motion of the particle and types of motion: rectilinear motion or a straight line motion, or linear motion, a circular motion, or rotatory motion, oscillatory motion, or a vibratory motion. Also, we are going to learn about the physical quantities, which are a scalar quantity and the a vector quantity. We are also going through a position, path length, which is nothing but the distance, and the distance of an object. Before going to know about the motion, we have to know about what you mean by rest. When can you say that object? When can you say the object is in a rest? Okay, we use the word rest in our daily life, which means a stopping work or movement in order to relax, recover strength, or sleep. In physics, the word rest conveys a specific meaning. If we look at our surroundings, we can easily find the objects which move and which do not move, right? We can see and we will get to know whether the object is in motion, whether the object is in just not moving at all. For example, the earth, the moon, hands of a working clock, water in rivers, flying aeroplane, flying birds, etc. All move, right? Whereas the trees, electric poles, buildings, towers, bridges, they do not move, right? So what do you mean by rest? In physics, rest and motion are two different states of an object, right? If the object is or if it is moving, the object is in motion. If the object is not moving, the object is in rest. So we also consider a few parameters to say whether the object is in rest in physics. An object is said to be in the state of rest if it does not change its position with the time. So you have to consider this with the time and with respect to its surroundings. Then the object is said to be in a rest a position. Right? For example, the sofa in your living room. For example, if you're sitting idle and not doing anything, with respect to the other, let's say other persons around you, they are moving. With respect to them, you're not moving. You're just sitting idle, and the time, according with the time in the given time, you're not moving at all. Then you're said to be in a rest position. One more example. For example, you just turned on a fan and you're sitting under the fan. You're relaxing. Okay, so with respect to the time, okay, you're not changing your position with respect to the surroundings. You're not changing your position. You're said to be in a rest position. Let us see what is motion. I just told you, right? You're sitting under a fan. You turned on the fan. If you observe the fan is in a motion, which is a circular motion. It's rotating, right? With respect to you, with time, with the surroundings, with respect to you, when it's considering from your side, the fan is in motion. It is in a motion. So what do you mean by motion? An object is said to be in the state of motion if it changes its position. Before you turn on the fan, Before you turn on the fan is in a state of rest. It is not moving because there is no a power supply. And when you turn on the fan started to move. The fan started to rotate. With a given time, if anything that doesn't remain in a stationary, which the alternate meaning, if the object is in not in a position of a rest, and then the object with respect to its surrounding, then the object is said to be in a state of a motion. Simply, if the object is not moving, if the object does not move with the time with respect to its surrounding, we call it is rest. If an object is said to be in the state of motion, if it is with respect to the time and surrounding, then the object is said to be in a motion. Let us see a few examples. For example, birds fly, right? And fish swim. Before also I told you many examples. Flying aeroplane, the waters in rivers, the water flow, right? And the moon, and the birds, they all are in a motion. If you see that the birds fly, it's an example of a motion. We can also see that the object of the fish a swim. A few more examples. For example, the blood flows through our veins and arteries. The blood, they are in motion. They are in motion. They are not in rest. They are 24/7. They are in a motion. For example, the cars move, right? As I told you, if you start a car, the cars move. They go from one position to the other position. They don't stay in rest position. They move. So these are the examples. Let us quickly read out. Let us quickly see once again what you mean by rest. Rest, an object is said to be in the state of rest if it does not change its position with respect to its surroundings. Whereas in a motion, an object is said to be in the state of motion if it changes its position with time and remains stationary with respect to its surroundings. The state of rest or motion, these are two relative in terms. Okay, state of rest and the state of motion, they are two relative terms. These states depend upon their surroundings. As I told you, for example, you are sitting under a fan. With respect to the fan, you are in rest position. With respect to the people around you, let's say they are moving, you are in a rest position. You're sitting, you're just getting relaxed. Okay, whereas the fan, it is in a rotation, right? With respect to the surroundings, the state of rest and the state of motion are two relative terms. These depend upon their surroundings. An object may be in rest with respect to one surrounding, but may be in motion with respect to the some other surrounding. These are relative terms. Let's see, one object from one perspective, from one surrounding, it is in rest. From the but maybe that object will be in motion with respect to the some other surrounding. Let us see. For example, a moving bus. Okay. For example, a moving bus. For a passenger sitting in a moving bus, the roadside trees and the poles appear to be in a motion. Whereas a passenger on the roadside waiting for bus see the coming bus and passengers sitting in it as moving. Did you get that? For example, see clearly that for the passengers sitting in a moving bus, the roadside trees and the poles appears to be in motion. Whereas a passenger on the roadside waiting for a bus sees the coming bus and the passenger sitting in it as moving. But a passenger inside, but a passenger inside the bus sees his fellow passengers to be at rest. See, two different surroundings. An object in rest with respect to one surrounding, whereas the object is in motion with respect to the other surroundings. In this example, for the passengers who is sitting inside, can see his fellow passengers, they are in rest. Okay, from his surrounding, from his perspective of view. Whereas the passengers who are waiting on the roadside, for their perspective of view, the passengers sitting inside the bus, they are in a motion. So it depends upon the the surroundings. It depends upon the surroundings, whether the object is in a motion, whether the object is in rest. One more example: the earth revolve around the sun appears to be rest to us. We don't see that. We don't physically, we don't see that the earth is rotating, because thus the both rest. This gives an explanation about the motion and the rest are relative terms. Okay, so here we can understand from the perspective of the surroundings, that we can take it as a reference point. A reference point is needed to describe the position of an object. The people, okay, the people who are waiting here for the bus, from their reference point, from their position, the reference point, the passengers inside the bus, they are moving. Okay, we need the reference point to describe whether the object is in motion, whether the object is in rest position. Whereas the passengers inside the bus can observe the fellow passengers, they are in rest. So we need the a reference point whether to describe the object is in motion or the object is in position. Okay, let us go to the next uh, what we have. Let's see the types of motion. Okay, before going to types of motion, let us recall what we have gone through. So what do you mean by rest? Rest, an object does not move with respect to time and to its surrounding. What do you mean by a motion? The object will change its position with respect to time and with respect to the surroundings. And also the motion and the rest, they are relative terms. To describe, we also have seen an example of the moving bus and the passengers waiting for the bus and the passengers inside the bus. Okay, we can also see that to describe whether the object is in motion or in a rest position, we need a reference point. Now let us go to the next topic: types of motion. Generally, we have three types of motion. In the beginning of the session, we have seen three types of motion: rectilinear motion, circular motion, and the oscillatory motion. Let us go through the first type: a rectilinear or a straight line motion. What do you mean by a rectilinear motion? Can you think of any example? What do you mean by a rectilinear motion? A rectilinear motion, if an object has a motion along a straight line, then we can say that that object has a motion, is a type of motion which is a rectilinear motion, motion along a straight line. Then the object is said to be in a straight line motion. Let us see an example. You can see that the car moving in a straight line path. It is moving in a straight line path. The motion of this car is in straight line. This is an example of rectilinear motion. You can see another example: a person walking. The person is walking straight. This path is a straight. The walking of a man in a straight line, a motion. Okay, let us see the next type: circular motion. As I have taken the first example, as I told you that you're getting wax underneath a fan. The fan, it is in a circular motion. When you turn on the fan, the fan is fixed to one point, whereas the blades of the fan, they are in a motion. They are rotating. They are in a circular motion. Any object has a motion along a circular path, then the object is said to have a circular motion. A motion along a circular path, then the object is said to have a circular motion. Let us see an example. A boy, a girl, one of the person holds a string and tied any object, for example an eraser or any object, to that thread, and he swings it in a circular position, whereas the person stood still, the fixed point, and rotating the object. Let us go to the third type of motion: oscillatory or a vibratory motion. What do you mean by oscillatory or vibratory motion? Any object that has to and fro motion Okay, any object that has to and fro motion about its mean position. Whereas if you see that straight line motion, the motion is in a straight line path. If you observe that, okay, circular motion, the motion of the particle is in a circular path. Whereas the oscillatory or vibratory motion, the motion of the object is to and fro about its mean position. For example, the pendulum of a clock. From its mean position, it oscillates to and fro. These are the types of motion: rectilinear or straight line motion. If the motion of along a straight line, then we can say that the object has a straight line motion. Circular motion, the motion along a circular path, then the object is said to have a circular motion. If the object oscillates to and fro about its mean position, then we can say that the object is in a oscillatory or vibratory. Let us go to the next topic. Physical properties. Physical quantities. What do you mean by physical quantity? It is a physical property of a material that can be measured. Okay, what do you mean by physical quantities? It is a physical property of a material that can be measured. Those are of two types. The first one is a scalar quantity. Okay, so these are the quantities that defines the property of a material. Okay, what do you mean by physical quantity? The property of a material, whether it is let us see, those are of two types. Scalar quantity, the first one is a scalar quantity. It is a what do you mean by scalar quantity? It is a physical quantity having only magnitude, not a direction. See, simply, what do you mean by magnitude? Any numerical value. Okay, just remember any numerical value. For example, a time, 1 hour, 2 hour, you measure it, right? You can measure it, but you don't say the direction of the time. Okay, for example, you're walking. Okay, we can measure the distance for your journey. You're walking, but you cannot. If there is no direction, you can say that object has that object comes under the scalar quantity. For example, speed and the distance. You can go at a speed of 30 kilometers per hour, 50 kilometers per hour, but you don't give the direction. Distance, you calculate the distance from initial position to the final position. Next, a vector quantity. What do you mean by vector quantity? It is this quantity where this physical quantity having both magnitude as well as the direction. It should have both the magnitude as the direction. Velocity, for example, velocity, acceleration, displacement. Displacement is it is the shortest distance from one position to the other position. It has a specific direction. You take the direction. You take the direction of the shortest distance from the initial position to the final position. Force. You apply force to a particular direction. You apply a force of 10 Newton to a particular direction. Momentum. Move. You walk to the particular direction. Any quantity which has any physical quantity that has a magnitude, I told you simply magnitude, a numerical value. For example, force, 10 newtons of force, 10 newtons, that numerical value, and a direction. Okay, so any object that has both magnitude as well as the direction, that comes under the vector quantity. So physical quantities, it is a physical property of material that can be measured. It has two types: scalar quantity, vector quantity. Scalar quantity has only magnitude but not direction. Vector quantity has magnitude as well as the directions. Let us see what are the physical quantities of a motion. Distance, the total path covered by an object. Displacement, the shortest distance between the initial position and the final position. A uniform or non-uniform motion, right? Object have motion, they move in uniform or non-uniform motion. We will discuss that. A speed, how much speed the object is in, how much speed the object has. If the object is in motion, they will have speed, right? And the velocity, okay, and the acceleration, rate of change of velocity, distance, displacement by time, and also the graph and equations of motion. These are the topics that we will cover in the next class, but these are the physical quantities of a motion where you can measure. What is a physical quantity? That can be, it is the property of a material that can be measured. What are the physical quantity of motion? These: distance, displacement, uniform or non-uniform, speed, motion, speed, velocity, acceleration, graph and equations of motion. These are the physical properties of material that can be measured. Let us see. Let us see the first one, the first physical property of a motion: a distance. Everyone, we all know, right? Distance. If you're going, we calculate the distance from our home to the school, right? According to the distance, we calculate the time, and we start to the school before 30 minutes or 1 hour according to the distance. But what do you exactly mean by the distance? Distance is the total path length. Okay, it is a path length that is covered by an object, or simply distance covered by an object is the actual path covered during the given time by the object, and it does not depend upon the direction of a motion. Okay, so distance is simply the total path covered by an object in given time. Remember, distance is a scalar quantity. It has the numerical value magnitude. You can calculate 10 kilometers. You can say that my house is 10 kilometers away from the school, but it doesn't have the a direction. Okay, that is a distance. For example, let us see the path here: A, B, C, D, E, F, G. So this is the path covered by the object. An object moves from A to D, and it goes to C, and it is the D and E, F and the G. Okay. Let us see. Let us go to the next one. The distance covered has only magnitude. As I told you, the distance covered has no direction. It is always positive. You remember that the distance is always positive. You don't calculate the distance in negative. You don't say that my house is minus 10 kilometers away from the school, and the distance is a scalar. It is a scalar quantity. Okay, it has a magnitude but not the direction. Let us go to the next one: a displacement. The displacement of an object is defined as the shortest distance from the initial position to the final position of the object during a given time. See, here we have an example. Okay, here we have an example. This is the path covered by the object from A, B, C, D, E, F, G. This is the total path covered by an object, that is the distance. But what do you mean by displacement? The displacement of an object is defined as the shortest distance from initial position. See, here in the above given example, the initial position is A and the final position is G. So what do you mean by displacement? Displacement is the shortest distance. Okay, so when you are calculating this displacement, you don't calculate the total distance covered by the object from A, B, C, D, E. Here in this example, you calculate directly the shortest distance. What will be the shortest distance? Calculating directly from A to G. Okay, the displacement is the shortest distance from initial position A to the final position G. That is the displacement. See, distance is a total path covered, whereas the displacement is the shortest distance that you can find from the initial position to the final position. Okay, and as I told you, the displacement has magnitude as well as a specified direction. It is a vector quantity. See, when you are calculating a displacement from A to G, you take the specified direction from A to G. You calculate A to G. So it is a vector quantity. Let us see few more things about the displacement. The magnitude of the displacement is equal to the distance travelled by an object only if it continues to move along a given straight line in a given direction. See, the displacement is equal to the displacement. Observe this. The displacement is equal to the distance covered. When is that possible? If the object is in a straight line motion. See, if the object is in a straight line motion, the distance, total distance covered will be equal to the displacement, because the total distance covered itself is the shortest distance, because the object is in a straight line. It is not going in a, it is not taking any turns, right? It is in a straight line motion. So the displacement, the magnitude of the displacement is equal to the distance traveled by an object. For example, you're going to a shop. You your body motion is only the a straight line. Okay, you directly went to the shop. From, for example, your house is at a position A and the shop is at a position a B. So the distance between A and B, your house and the shop, that is a path covered, and that is the distance. Whereas the displacement, the shortest distance from your house and the shop, which is nothing but from A to B. In this case, both the displacement and the distance are equal. That is the condition. If the object is in a straight line motion, if it is going in a straight line in the given direction, your direction from your house to the shop is straight, okay, in that particular direction, which north, east, west, north, south, whatever the direction, that particular direction, that if the direction is same from the beginning, from the initial position to the final position, then the object is said to be having same displacement and the distance. Okay, whereas, see, let us see one more. Magnitude of the displacement is less than the distance covered by an object if the direction of motion is not the same. Let's see. You went to a shop from your house to the shop. In the above example, you went straight directly to the shop. But let's see another. Let's say this way. If you're going to the shop, in between your friend calls, you change the direction, you go to him, and you talk to him, you wait for some time there, and you go to the shop. In this case, what is the displacement? The shortest distance covered in the whole distance. What is the shortest distance covered from your position, from your house to the wherever your friend is standing? That is the shortest distance. In this case, that is the displacement, right? The shortest distance covered in the from initial position to final position is displacement. In this case, the displacement is from your house to your friend, where this displacement is less than the total distance covered. And remember that displacement of an object can never be more than the distance covered. Always remember that displacement can never be more than, it can be lesser than the total distance covered, it can be equal to the distance, but it cannot be more than the distance covered. Why? Because the displacement is the shortest distance from the initial position to the final position of the movement of an total distance covered. Okay, so far we have gone through what is a motion. In order to know the motion, we have gone through the rest, a motion, and how the object moves, examples of motion, and the types of motion: rectilinear motion, circular motion, oscillatory motion, and the physical quantities that explain the property of a material and object, a scalar quantity, a vector quantity, and we started few of the properties of the motion. What are the physical properties of motion? Distance, displacement, uniform motion, non-uniform motion, speed, velocity, acceleration. These are all we are going to learn in the next class. Please write down if you have any questions. We will discuss and go through the class. Okay, and also go through the worksheets. You will have a few assessment questions. Go through the questions. Okay, thank you. Have a wonderful day.